Hello guys, welcome to another video. This one is paper 3-2 of A-level math of May-June 2020. So let's move on to question number 1. So find the quotient and the remainder when this equation is divided by this equation. So we have to do a long division for this one. So pretty easy. So 6x power 4 plus x cubed minus x squared plus 5x minus 6. Now divide by this one, which is 2x squared minus x plus 1. So step 1, how can you make 2x squared become 6x power 4? You have to multiply this by 3x squared, right? So this multiply this, you will have 6x power 4. Same thing, minus x times this will become minus 3x power 3 and plus 3x squared. So simplify, we have to minus everything. So minus this goes away. So plus x minus become plus. So minus become minus 4x squared plus 5x minus 6. Now how do you make 2x squared become 4x cubed? You have to multiply by plus 2x. Now same steps. This whole thing multiplied by 2x, you will have 4x cubed minus 2x squared plus 2x. So that will be cancelled. Minus 4 minus 2, that will become minus 2x squared. Plus 5 minus 2 become plus 3x minus 6. Now same thing. How do you make 2x squared become minus 2x squared? You have to times minus 1. So minus this, that will become plus x, and that will become minus 1. So these two goes away. So 3x minus x become 2x. Minus 6 minus 1 become plus 1, so minus 5. So as you can see, this number here, this equation here will be your remainder, and on top will be your quotient. So let's write this down. So quotient is equal to 3x squared plus 2x minus 1, and remainder is equal to 2x minus 5. And this is your question number 1. So let's move on to question number 2. So we have a graph here, as you can see, and we have a straight line with those 2 points. This is the graph of x, or ln y against x. So the variables x and y satisfy this equation, where a and k are constants. The graph of ln y against x is a straight line passing through the points this and this as shown in the diagram. So the first step, as you should do, so here we have to find the values of a and k correct to 2 decimal places. So first step is we have to convert this equation in terms of ln y and x. So let's do that. So first we have y squared equal to a e k x. Now for us to get ln on one side, we have to take ln y square. If you take ln on one side, you have to take on both sides. That will be a e k x. Now next step, we can simplify. As you guys know here, we can expand this to ln a plus ln e kx, and here we'll have 2 ln y. Now next step, we can simplify more. You will have 2 ln y equal to kx. ln e is equal to 1, so it become kx plus ln a. So ln y is equal to k divided by 2 x plus half ln a. So if you see, this is just like your normal equation of line, which is, so when you used to do a line equation, that is y equal to mx plus c. This is your y-intercept, this is your gradient, and this is your y. But in this case, it is ln y against x. Okay, so m is a gradient, is equal to k over 2. So since we have 2 points already, so 1.5 and 1.2, and 5.24 and 2.7, we can find the gradient, which is m. That will be y2 minus y1, so 2.7 minus 1.2 over x2 minus x1. So let's see what value you will have from this gradient. So let's find this. You will have 2.7 minus 1.2 divided by 5.24 minus 1.5. That will be 0.40. Correct to 2 decimal place. So this is the value of m. M is the same as the value of k over 2. So m is equal to k over 2 is equal to 0.40. So value of k will be 0.80. That is your value of k, correct to 2 decimal place. So now we have to find the value of a. So we have to use a point. So let's use the point 1, 5 and 1.2. 1.5, 1.2. Now since the graph that we have here is the graph of ln x against, so ln y against x, so this point will be classified as, this one will be your x, but this one will be your ln y because of the curve of the graph that we have. That's why we have to choose this as x and this is as ln y. So replace back in the equation that we have here. So you will have 1.2 is equal to k over 2 is equal to 0.4, x is equal to 1.5 plus half ln a. Now we can multiply by 2 everywhere. You will have 2.4 equal to 0.8, 1.5 plus ln a. Make ln a the subject of formula. You will have 2.4 minus 0.8 times 1.5, which is equal to what? 2.4 minus 0.8 times 1.5. That will be 1.2. So value of a will be equal to exponential of 1.2, which is 3.32. So correct to the 2 decimal place, you have value of a is equal to 3.32 and value of k is equal to 0.80. So your value of a can also be a 3.31 depending on your value of k that you took in this part. So this will be your question number 2. Now let's move on to question number 3. So it says find the exact value of this integration. So if you look, we have two kind of equation. So we have two kind of function. The first one is an x function, which is we call an algebraic function, and this one ln x is a logarithmic function, right? Logarithm. So when you have these two kinds of function, usually we have to use integration by parts, which is uv minus integration of du by dx and then v dx, right? That will be integration by part. So now we have to choose which one will be v and which one will be dv. So we have to choose which one will be dv or which one will be u. So how do we choose this? So let's look. The first one here we have algebraic and we have logarithm. So we have to follow a rule. It's called LATE, L-A-T-E. So this is the order of the way we choose which one will be u or dv. So the first one is logarithm, the second one is algebra, third one is trigonometry, and last one will be exponential. So here we have logarithm and algebra. So which one will we choose is happens first? As you can see, L happens first. So whichever happens first has to be u. So u will be the logarithm, which is equal to ln x, and dv will be equal to the other one, which is x 3 over 2. Okay, so when we know dv, you have to find v, which is integration of 3 over 2. That will be plus 1 divided by this value, that will become 2x 5 over 2 divided by 5. This will be v. Now we have to find du by dx, that will be 1 over x. So next step is to replace these values in this equation. So u is ln x, and then v will be what? V is equal to this, so 2x 5 over 2 divided by 5 minus integration of du by dx is 1 over x times v is given by this, 2 over 5 x 5 over 2 dx. So first let's simplify, and then we can just solve it. So simplify this, x goes away, 1x goes away, so that becomes 3 over 2. So integration of, so let's do this on this side, so integration of 2 over 5 x 3 over 2 dx, that will be, so 2 over 5 is right here, times x now plus 1 and divide by 5 over 2, that will become 4 over 25 x power 5 over 2. So simplify, you will have ln x times 2 over 5 power 2 minus 4 over 25 x power 5 over 2. Now, as always, you see we have a limit here. We have to find the values between those limits of integration, so 4 and 1. So let's do that. So the first one is 4. Let's replace. You'll have ln 4 times 2 over 5, 4 right here, power 5 over 2, minus 4 over 25, 4, 5 over 2, bracket, minus, let's use a different color, minus for the 1 now, that will become, ln 1 is equal to 0, so this will be 0, minus 4 over 25, this will be 1. So let's simplify. So for this part, that will become what? So what is 4 power 5 over 2? So 4 power 5 over 2, that will be 32. So here you will have 32 times 2 over 5, that will be 64. So we will have 64 over 5 ln 4 minus, this is 32 times 4. 32 times 4 will be 128. 128 over 25. And then we have minus become plus 4 over 25. So if you simplify, you will have 64 over 5 ln of 4 minus, so minus 128 plus 4, both have the same base, we can just add them directly. That will become minus 124 divided by 25. So this will be your answer, but if you want to simplify some more, you can. If you want to, you can do that. So what is ln 4? ln 4 is equal to ln 2 power 2, which is 2 ln 2. So 2 times 64, you will have 128 over 5 ln 2 minus 124 over 25. So this will be your exact value of this integration, but you can stop right here if you want to. And this one is integration by part. You have to choose the right u and right dv to find this value. This will be question number 3. Question number 4, we have a curve half equation y equal to cos x sine 2x. Now part 1, it says find x, the x coordinate of the stationary point in the interval of x between 0 and half pi, which is 90 degrees in the first quadrant, giving your answer correct to 3SF. So let's do that. As we know, the first thing we know is at stationary point, we know that dy by dx is equal to 0. So let's first find dy by dx. As you can see, y is equal to cos x times sine 2x. It is a product, so we have to use the product rule. So dy by dx is equal to, so we first keep the second one by itself, times dy by dx by, so the differentiation of this one, you will have minus sine x, then plus, we leave the first one alone and then differentiate this one. You will have 2 cos 2x. So simplify, you will have minus sine x sine 2x plus 2 cos x cos 2x. Now we can replace those values. As you can see, this is double angles. The formulas will be given to you on your formula sheet for double angles. So let's write this down. What is sine 2x? So sine 2x, it can be, we have a few options, but I will choose this one, which is 2 sine x cos x. And this one will be, what is cos 2x? So here also we have a few options. We can choose either way. I will choose 1 minus 2 sine square x. And again, these formulas are given to you in the formula sheet. You don't need to memorize. Okay. So now we just need to replace back in the equation. You will have minus sine x times this. You will have minus 2 sine square x cos x plus 2 cos x times 1 minus 2 sine square x. So let's simplify again. Let's take our time. So minus 2 sine square x cos x plus 2 cos x minus 4 sine square x. So now what is the other option? As you can see, we have something which is matching. What is matching right here? So these two can be simplified. Oh, sorry, this is a mistake right here. This should have been, this one is actually equal to, so we have 2 cos x times 2 sine square x, so that will be minus 4 sine square x cos x. Right, so this is not right, this is the right expansion. Now let's have a look to see what here we have. As you observe, here we have the same thing, so sine square x and sine square cos x, same thing, right? So we can simplify this. Here you have 2 cos x minus 6 sine square x cos x. That will be my expansion and simplification. So now you observe we have cos and cos x, same here. We can take it out. You will have this. Let's take 2 out as well. You have 1 minus 3 sine square x. And this will be your dy by dx. So now we have to equate this to 0 because we want to find the stationary value. Now, this is factorized already. We have to find one by one. So first one is 2 cos x equal to 0. And then for this one we have 1 minus 3 sine square x equal to 0. So as you know, x will be cos inverse of 0, which is pi by 2. But we are only looking values for between 0 and pi by 2, not including pi by 2, so that will not be in the range. And for this one, let's make sine square the subject. So sine square x is equal to 1 over 3, and sine x is equal to plus minus root of 1 over 3. So, but we're looking for only values in the first quadrant. So let's find only the positive value of sine. So sine will be, sine x will be sine inverse of root of 1 over 3. So in terms of pi, we should have root of 1 over 3, sine inverse of that should give you 35.3 degrees. So now in terms of radians, so actually we need to find radians, not degrees. So change your mode to radians. So root of 1 over 3, sine inverse of that should be 0.615 for the value of x. So that should be your only value in the first quadrant because our condition is from 0 to half pi. So your answer is x coordinate will be 0.615. And this is your question number 4. question number 5, we have to express this in form of r cos x plus alpha, where r is positive and alpha is between 0 to 90. So give the exact value of r and the exact value of alpha correct to 3 decimal place. So as you can see, if you have something in the form of, you see, so here we have cos x minus something sin x. So let's write this down. If it was a cos x minus b sin x equal to r cos x plus alpha, the value of r is equal to square root of a square plus b square. The value of alpha will be tan inverse of b over a. So let's find those values. So here we have root 2 of cos x minus root 5 of sin x. So the value of r is equal to root of a square will be 2, b square will be 5, that will be root 7. Alpha will be tan inverse of b over a, b will be root 5 over root 2. So we need this answer correct to 3 decimal place. So root 5 divided by root 2, tan inverse of that should be, we need in degrees. So degrees, root 5 divided by root 2, in terms of degrees, that will be 57 to 3 decimal place, 688. So replace back, you will see that this is equal to r is root 7, exact value, cos of x plus alpha, which is 57.688. This will be what you need to show. Now let's move on to part B. It says to hence solve the equation of this. So how would you solve this equation? So the only difference from the first part, here we have 2 pi instead of x. So same thing, we just have to replace x by 2 pi. So basically this is equal to root 7 cos of x becomes 2 pi, and we have plus 57.688 equal to 1. So we have to solve between 0 to 180. So as always, make cos the subject of formula. You will have this 1 divided by root 7. So cos is positive, it will be in this quadrant and in this quadrant. This is theta. This will be 2 pi minus theta, usually, right? Now let's find the value of cos inverse. So 2 theta plus 57.688 equal to, so cos inverse of that will become, so 1 divided by root 7, cos inverse of that will become 67.79. And then the other value will be 2 pi, which is 360, minus that will become 292.21. So now since we have 2 pi here, what we can do is, even though our limit is between this and that, we can do something. If we have 2 pi, let's make sure we add 360 to each of those values so we don't miss anything just in case. So let's add 360 to this one. We will have 67.79 plus 360. That will be 427.79, and 292.21 plus 360, that will become 652.21. So let's find the value of theta. So 2 theta is equal to what? So everything minus this, 67.79 minus 57.688, that will be 10.1. This one will be 292.91 minus 57.688, that will be 234.52, and we have 427.79 minus 57.688, that will be 70.1, and then we have last one 57.688. You will have 594.5. Now to find the value of theta, divide everything by 2. 10.1 divided by 2, that is 5.05. Now to one decimal place for degrees, that will be 5.1, and the rest will be 234.522 divided by 2. That will be 117.3. 370.1 divided by 2. That'll be 185.1, and then last one 574.5 divided by 2. That'll be 297.23. Sorry. So now, as you have known from the first part here, theta is between 0 and 180. So let's see, outside the range will be, this is past, so we only have two values, 5.1 and 11.7.3. So this will be your two values of theta. That is your answer. So let's write it again. Theta is equal to 5.1 degrees and then 11.7.3.3 degrees. The reason why we do all this is because just in case when we have two revolutions, sometimes the values may overlap to the other revolutions. So just in case, we have to check if that can happen. So in this case, it did not. So the only two values will be this and this. That will be question number 5. Question number 6. The diagram shows the curve y for x more than 0 for positive value of x. Now, its maximum point is m. As you can see, m is right here. So part 1, find the x coordinate of m, giving your answer correct to 3 decimal place. So it says m is a maximum point. As you know by now, at max point, m, dy by dx has to equal to 0. So let's do this. Let's find dy by dx. So y is equal to x divided by 1 plus 3x power 4. So this, as you can see, it's a quotient. We have to use the quotient rule. So let's do that. So dy by dx is equal to, that will be 1 plus 3x power 4 times differentiation of this one, that will become 1 minus x the same. Then you will have differentiate this one, you will have 12x power 3, and everything divide by the base square. The base is 1 plus 3x power 4 square. So you can simplify if you want to. So you will have 1 plus 3 power 4 minus 12x power 4 divided by 1 plus 3x power 4 square. So as you have seen here, this needs to be equate to 0 to find the maximum point. So as always, whenever you have this, you can cross multiply. You will have 1 minus 9 power x equal to 0. So you make x the subject of formula, you will have 9x power 4 equal to 1. So x power 4 equal to 1 over 9. So x is equal to 1 over 9 power 1 over 4. So just to explain, how do I get this? So basically, when you have x power 4 and this is 1 over 9, so if you want to get rid of, let's say you want to remove this power 4, you have to take powers of 1 over 4 on both sides. So this one will go away. So that's why you have x is equal to 1 over 9 and power of 1/4. So let's do that. 1 over 9 power of 1 over 4, that should be 0.577, correct to 3 decimal place. This is your value for x coordinate of m. So now let's move on to part B. Part B says, using substitution of u equal to this, find the integration of the exact area of the region bounded by the curve, the x-axis, and the line So let's find that. So as you know by now, how do you find area under the curve? You will do integration of 1 and 0 and y by dx. That's how you will do it usually, right? So let's do this right here. So let's write down. Usually you will just take integration between the limits of 1 and 0 of y by dx to find the area of that region. Now you have to use u as your substitution. So now we know y has been given to us as x over 1 plus 3x power 4. So we have to use u as root 3 x power 2. So now what happens if I square u? Let's say I square u. You will have 3x power 4. So 3x power 4 is equal to u squared. You can replace here, right? Now let's say du by dx will be equal to 2 root 3 times x. From this you will have dx is equal to du divided by 2 root 3 times x. Okay, so for having this, now we have to change the limits as well. This is the limits for x. We have to change it to u. So for the value of x equal to 1, the value of u will become u equal to root 3 times 1 squared, that will be root 3. Now for the value of x equal to 0, u will equal to 3 times, root 3 times 0 squared, that will become 0. So your new limits will have been changed to these two values. So now you have the new integration, which is root of 1 become root 3, that will be 0, and y is x over 1 plus, as you have seen here, 3x power 4 is equal to u squared. And here we have du over, so dx is du over this, so dx here become du over 2 root 3 times x. So now if you observe, x cancel out, you will have integration of root 3, 0, 1 divided by 1 plus u squared, and this you can take it outside if you want. You can just take it outside, so this, that will be du. Now if you observe this, so in your formula sheet they will provide you with the answer already. This is integration of this, so integration of 1 plus u squared du is equal to tan inverse of u. This will be given to you in your formula sheet. Okay, so let's just replace. You will have 1, 2 root 3 limits of tan inverse of u between root 3 and 0. So let's replace and find the values. So 1 over 2 root 3 bracket, first one is tan inverse of root 3 minus tan inverse of 0. So this is 0, and this will be, let's find out. So tan inverse of of root 3 will be 60 degrees. Okay, so we need this in terms of radians. So pretty easy, 60 degrees will be pi by 3. So let's simplify. This will be 1 over 2 root 3 times pi over 3. That will become pi over 2 times 3 will be 6 root 3. So this could be your answer if you want to. This will be your answer. But if you want to simplify ahead, you can do that. You can just multiply by root 3, so you can multiply. So you have 6 root 3. You can multiply by root 3 on the base and on the top as well. You will have, here you will have root 3 times root 3 is 3. You will have 18. So root 3 over 18 pi units squared. So this will be your answer. This can also be your answer for this question. This is question number 6. Now let's move on to question number 7. The variables x and y satisfy this equation. Now it is given that y is equal to 2 when x equal to 0. So we have to use this later on to find the constant of integration. Part 1. Solve the equation obtaining an expression for y in terms of x. So step 1, we have to send x to one place and y to all the y's to one place. So here we have dy on one side, and here we have y minus 1 over x plus 1, x plus 3. So we have the x here. The first step we can do is we can just cross multiply. So if you cross multiply, So we can send dx over here, and we can send this one over here. So we can just leave this one here because we will bring ds on this side, we will bring y on this side. So we don't need to cross multiply, we just need to send this one on this side and this one on this side. You will have 1 divided by x minus 1 on this side dy equal to 1 over x plus 1 and x plus 3 dx. So basically we have to regroup all the y's together and all the x together. So we find a way to do that is by bringing this one here and bring this one over here. Now we have to apply integration to solve to find the value of y and x. So this one is pretty easy. Let's do this on this side. Integration of 1 divided by y minus 1 dy is simply equal to ln of y minus 1. Now for this one, as you can see, we have to use partial fraction. So how can you find the values of the fraction? We can break this down. So let's do this. Let's say let's call this fraction f of x. Let's call this f of x. So let f of x equal to a over x plus 1 plus b over x plus 3. So because these two are linear, as you can see, these two are linear linear equations, we can just have a and plus b on top, right? Now we have to find the values of a and b. So we have to simplify. You will have a x plus 3, so you just cross multiply, plus b x plus 1. Now we have to expand. You will have ax plus 3a plus bx plus b. Now regroup everything together. You will have a plus b bracket x plus 3a plus b. Now we have to compare, right? F of x was equal to what? On top we had 1. As you can see, on top we had 1. So 1 on top. So the base here is just x plus 1 and x plus 3. And the base for f of x is the same, x plus 1 and x plus 3. So these just cancel out, we don't need them, so cancel out. So we just have to compare the coefficients. So as you can see, here we have no x, so basically 0x plus 1, so we have no x. So which means a plus b is actually equal to 0, so that's our first equation. Let's write this down here. A plus b is equal to 0 by comparing the coefficients. A will be minus b, and this one is 3a plus b is equal to 1. 3a plus b is equal to 1. So replace the value of a here. You will have minus 3b plus b is equal to 1. So b will be equal to minus half. So a will be equal to half. Now you bring all this back to this part, which is, this is f of x. So let's write this down here. F of x is equal to a is half of this one, 1 over 2 times x plus 1 minus 1 over 2 times x plus 3. So we have to replace this back here to solve this integration. So whenever you see something like this, you have to break this down into two parts to solve them, to solve the integration. So let's solve this one now. Integration of f of x dx is equal to half of ln x plus 1 minus half of ln x plus 3. So let's make some more space because we don't have much space. So basically now what do we have? On one side we had, let's rewrite everything down. So on one side we had integration of 1 over y minus 1 dy is equal to integration of 1 over x plus 1 x plus 3. So that was our initial integration. So we found out that this side became ln of x minus 1, and this side, because of this breakdown, it became this, right? It became half of ln x plus 1 minus half times ln x plus 3. So when you integrate, you have it constant, you say plus c. Now we have to find this value of c. We have to use the the values given to us from y and x. So let's bring this down on this new page so we can have more space to explain. So right now we have ln y minus 1 is equal to half ln x plus 1 minus half ln x plus 3 plus c for the constant of integration. So we have been given that when the value of y is equal to 2, the value of x is equal to 0. So replace these values back in the equation to find the value of c. So first one, ln y is 2, 2 minus 1 is 1, equal to half. X is 0, so that will be ln 1 as well, minus half ln 3 plus c. Now these ones will become ln 1 is equal to 0, ln 1 is equal to 0, so 0 times half will be 0 equal to 0 minus half ln 3 plus c. So from this you observe c is equal to half ln 3. Right. So basically if you put this back in the equation, you will have, our equation will be equal to ln y minus 1 is equal to half ln x plus 1 minus half ln x plus 3, and finally c will be half ln 3. Now to get rid of this 2, we can multiply by 2 everywhere. So you will have 2 ln x minus 1 equal to ln x plus 1 minus ln x plus 3 plus ln 3. Now you can combine all these ln together. When you have minus is divide, when you have plus is multiply. So here is the same, so ln x minus 1 equal to ln, so when you have minus is divide, so x plus 1 divided by x plus 3. When you have 3 is multiply, so 3 multiplied by the top. So simplify again. Here you will have ln y minus 1 square is equal to ln 3x plus 1 over x plus 3. Next step, we have both sides, we have ln, we can cancel, ln goes away. So here we have y minus 1 is equal to square root of 3x plus 1 over x plus 3. So finally, value of y is equal to, we send 1 over here, you will have 1 plus root of 3x plus 1 over x plus 3. So that will be expressing y in terms of x for this question. And this is your question number 7. Question number 8, we have to solve this equation. Give your answer in the form of x plus iy. So pretty easy. Let's say y is in the form of x plus iy. So y conjugate will be in the form of x minus iy. So we just have to replace those values inside and expand. So on one side we have 1 plus 2i times w, which will be x plus iy. This side you will have plus I times this one will be x minus iy. If you expand, you will have x plus iy plus I 2x, and then you will have plus I square 2y, and here you will have plus I x minus I square y. So you have to know that I square is equal to minus 1. Replace. Here you have x plus iy plus I 2x. This will be minus 2y plus ix. That will be plus y. So now we have to regroup all the real parts and the imaginary parts together. So here we have I, and I. We have to put it together. And here we have real, real, and real. So here we have x plus y minus 2y on one side. And then, let's say plus, and then you have iy plus I 2x plus ix. So let's simplify again. We can see here you have x, what is y minus 2y will be minus y. We have plus, this will become, we have 2x plus x, that will become iy plus I 3x. So one more time we can take out I here, so x minus y plus I outside x plus, sorry, y plus 3x. Now this is equal to, on this side, equal to the 3 plus 5i, right? Now this is we have to compare the coefficients, so the real part here is this, so x minus y is equal to 3, and this part will be equal to this, so y plus 3x is equal to 5. Now we have to solve them simultaneously to find the value of x and y. So y is equal to x minus 3, replace y here, you have x minus 3 plus 3x equal to 5. Now x plus 3x, that will be 4x equal to 8, x will be equal to 2. Now y is equal to 2 minus 3, which is minus 1. So we place this value back in the main form, as we have said, w is equal to x plus iy. From this we have w, the solution will be equal to x, which is 2, plus I times minus 1, which is 2 minus I. This will be your value for w, and you have solved your equation. That is. So let's move on to part B of question number 8. It says, on a sketch of an organ diagram, shade the region whose points represent the complex number z, which satisfy this inequality. We have this and this. So first let's find out what is the meaning of this. So we have modulus of z minus 2 minus 2i modulus of less than equal to 1. So we have to rewrite this. So basically z, take out minus, you'll have 2 plus 2i. So the meaning of this is this will be a circle of radius 1 with center 2 and 2i. That will be your center of the circle. This is what it means. And this one will be a line. So here we have minus 1/4 pi. As you guys know, 1/4 pi is equal to 45 degrees. Minus 1/4 pi is just minus 45 degrees. So what does minus mean? Minus means the direction. So usually when your angle is positive, you will go in this direction. But your angle is negative, it will go in this direction. For example, minus 45 will be below, it will be in this direction, 45. Right, so that is just the example. Now, as you can see, we have minus 4i. This will be the point where you will start drawing your arc of this, of the point Z. So, as always, before we draw a graph, we have to draw the axes. The first one is the imaginary axis, and we can draw the real axis on this part. Okay, so we can label them. This is the real, and this is the imaginary. So let's try to use some scales. So we have 1, 2, 3, 4, 5. Here we have 1, 2, 3. So I don't have much space here, so let's try our best to make it fit. So that will be 1, 3, 5. Okay, so let's label this. So this will be 1, 2, this is 0, 3, 4, 5. This is your real axis. This is your imaginary axis. This will be I, 2i, 3i, and 4i. You write 5i if you want to. So the first one will be a circle from the point 2 and 2i. So 2 is here, 2i will be right here. And the radius is equal to 1. So radius will be 1. So 1 will be here, 1 here, 1 will be right here, 1 will be on top. So we don't need to draw, we have to sketch. So you don't need to be exact with those values, but try your best to make it as accurate as possible. So let's join this by a circle. So if you have a compass, please use a compass. That will be a better circle than this. Okay, use a compass if you have a compass. So this will be the first one. And how about this one? From the point 4i, we have to draw this minus 45. So pretty easy. So this, let's say this is our horizontal axis. Minus 45 will be the angle right here. It will be going through 4, 4. Now let's shade the region that we need. So it says it will be less or equal to 1, so it will be this one, and then this will be more than this, it will be above this line. So the region that we need will be this region. Okay, so this is a circle and this is a straight line, and we have to shade that region that represent these two inequalities. That will be your question part B. Now for part 2, find the least value of the imaginary part of z for the points in this region, giving your answer in exact form. Now let's observe. So in this region that we have shaded, where is the minimum value, the least value for z, for the imaginary value? So let's see. In this region, where is the least value? You would say this is the max value, and the least will be right here. The least value will be about this value. So we have to find this reading for this value of z. Now, how do you find this? You have to play with the object. So here you have your center of rotation, on the circle. And if you observe, here we have to find this distance. So we have to find this distance. Let's call this y. We have to find this y. So we know what is this value, what is this reading for this answer. So this is, the radius is 1. So let's take this out. We have y here. Right? So this reading here is 1 because it's the radius of this circle. And we know this is 90 because we are trying to find this perpendicular by these two lengths. And what is this angle? So because this is 45, this also will be 45. Right. Now we have to find y. So we can use SOHCAHTOA. So in this case, we know this side. This is the hypotenuse, and we know this side. So what can we use here? So this is the hypotenuse. So let's use SOHCAHTOA. So we know the hypotenuse, and we are trying to find this side is our opposite side. So sine of 45 is equal to y over 1. So y is equal to, y will be equal to 1 times sine 45. So sine of 45 is equal to 0.707, but the exact value is actually root 2 divided by 2. That is the value of sine 45 for this value of y. So you can find this by using your table. Usually you would know that tan 45 will be equal to 1. So from this you can derive that this is equal to this. Now we want to find this value here, this value here. We know this distance, so that will be 2i, so 2 minus this. So the least value will be, so the least value is equal to 2, which is I, minus root 2 over 2. That will be your least value for this point in that region, and you need to provide the exact value for your answer. That will be question number 8. Let's move on to question number 9. The diagram shows the curves y equal to cos x, which is this one, and y equal to k divided by 1 plus x, which is this one. Now, these two curves meet at this point where x equal to p, right here. Now, x is between 0 and half pi, as you can see. It is between those two. The curve touches at the point where x equal to p. So the curve meet at this point. Now, question, show that p satisfies this equation. So let's do that. How can we do this? So y is equal to cos x and y is equal to k 1 plus x. So basically at the curve right here, we know that they have the same gradient at this point. Because they meet at the point, they have the same gradient, so that means dy by dx is the same. So let's do that. Find dy by dx for this one. So dy by dx for this become minus sine x. This one will become dy by dx becomes what? That will be, so if you rewrite this down, we have k x plus 1 plus x power minus 1, so become minus k x plus 1 plus x power minus 2. That will become minus k over 1 plus x power 2. So they have the same gradient. So this is equal to this. So we write down minus sine x is equal to minus k 1 plus x power 2. So now what can we do now is, as we know, they meet at the point x equal to p, so replace x by the value of p. So you have minus sine p is equal to minus k. So basically this is the same at this point. So at x equal to p they meet, right, because they have the same gradient at this point. Now we have 1 plus x power 2. So x is p actually. So now we have this equation. We have to simplify further to have this value. So if you observe, we have to eliminate this k. Now going back to the main equation, k is equal to y times 1 plus x. And y is equal to cos x. So replace y here, you have k is equal to cos x and 1 plus x. So in this equation right here, we say at x equal to p, so basically k is equal to cos p and 1 plus p. Now replace this back here, you will have sine p, so minus minus cancel out. Sine p is equal to k, which is this, cos p 1 plus p divided by 1 plus p square. So you can do something, you can send cos on this side and this cancel out, so remaining will be sine p divided by cos p is equal to 1 over 1 plus p. Sine over cos is tan p is equal to 1 over 1 plus p. This is shown as required. As you can see, we need to show this, and this is shown as required at the point x equal to p. That is part A. Now let's move on to part B. Here we have use the additivity formula, which is p n plus 1 equal to this, to determine the value of p correct to 3 decimal places. Give the results correct to 5 decimal places. So the value of x, as we have seen right here in the equation, is between 0 and half pi. So what is half pi? Pi divided by 2, that will be, so 0, 1.57. So what is, let's find the midpoint of x. Midpoint will be divided by 2, 0.78539. So let's take the value as the midpoint of this range. So you will say let x1 equal to, so the first value x1 will be equal to 0.78539. So x2 will be what? So let's find the value. So x1 is 0.78539. So we have to find tan inverse of 1 divided by 1 plus answer. So second value will be, so this is in degrees, we have to use radians. So answer is 0.78539. Tan inverse of 1 divided by 1 plus answer. That will be, second value is 0.5 0.51057 to 35 decimal place. X3 is equal to 0.5847 7. X4 we have 0.56291. X5 0.56912. X6 0.56737. X7 0.56790. X8 0.56775. X9 0.56779, and X10 0.56778. X11 0.56778, and X12 will be 0.56778. So as you can see, these three values did not change, so your answer will be X is equal to, correct to, 3 decimal place will be 0.568. That is your value for X. Now part C, hence find the value of K, correct to 2 decimal place. So you have to use the equation. So as you have seen, we have two equations, y is equal to cos X and y is equal to K divided by 1 plus X. Now, so we have found out the value of X is equal to 0.568. We have to find the value of K. So pretty easy. So first thing, we have to replace X right here. You'll have y is equal to cos of 0.568. So cos of 0.568, that will become 0.84297. That is your value for y. Now y, put this y right here. You have 0.84297 equal to k over 1 plus x is 0.568. So k is equal to, we have just to cross multiply, times 1 plus 0.568. That will become 1.32, correct to 2 decimal place. That will be your value for k. And this is question number 9. Okay, so let's move on to question number 10. So with respect to O, the points A and B has position vectors OA and OB. So OA has been given to you as 6, 2, and 0. And OB has been given to you as 2, 2, and 3. So the first information we have is the midpoint of OA is M. So the midpoint of OA is M. So OM will be half of OA, which is 310. So OM is equal to this. That's the first thing we can find. Now, the point N is lying on AB between A and B such that AN is equal to 2 times NB. So let's say you have a line. This is A and this is B. You have a point N which is such that this is AN 2 and NB is 1. So which means AN is 2/3 of AB. Right. Now let's first find AB. AB is just OB minus OA. So OB is 2, 2, 3 minus OA, which will be 6, 2, 0. That will be 2 minus 6 will be minus 4, 0, and 3. That will be the first part. Now we have to find AN. AN is equal to 2/3 of AB, which is minus 4, 0, and 3. So let's find what we have. 2 times minus 4, that will be minus 8 over 3. This will be 0, and this will be 2. So AN is equal to this. So we know that AN is equal to ON minus OA. ON will be equal to AN plus OA. So AN is equal to this, which is minus 8 over 3, 0, 2, plus AB plus OA. OA is given to you as this, so 6, 2, 0. So let's see what do we get. So minus 8 over 3 plus 6, that will be 3 1/3, that is 10 over 3, and that will be 2, 2. That will be your vector ON. So now you have to find the vector equation for the line through MN. So to find the line through MN, we first have to find the direction of MN. So direction will be ON minus OM. ON is right here, which is 10 over 3, 2, 2, minus OM, which is here, 3, 1, 0. So that will be equal to, so 9 over 1 over 3, this will be 1 and 2. So that will be your direction for this line MN. Now, how do you find the equation of a line, of a vector line? So how do you find a vector equation of a line? So you will know, it looks like R is any point is equal to, this is any point on line plus a multiple, we call this lambda, times the direction of the line MN. So we have found the direction already, so this is this one. And any point on the line, we can choose any point. You can choose M or you can choose N. It is up to you. So I will choose the point M. So R will be equal to M, which is 3, 1, 0, plus lambda. Direction MN will be 1 over 3, 1 and 2. So this will be your equation of line for part A. Now let's move on to part. Okay, so now moving on to part B. The line through MN intersect the line through OB at the point P. So we know that the equation of MN is given by R is equal to, so if we have found this in part 1, let's write this down. It is equal to 3, 1, 0 plus lambda times 1 over 3, 1, 2. And the line through OB is given by R is equal to, since it goes to the point 0, we don't need to write 0, 0, 0. We can just skip that. We can just write the direction of OB has been given to us by 2, 2, 3. Now, for them to meet, their R has to be the same, so we have to replace them simultaneously. So the first one will become, on this side we have 3 plus 1 over 3 lambda, 1 plus lambda and 2 lambda. This will equal to 2 mu, 2 mu and 3 mu. So the first equation we have will be, let's write this one, which is easier. 1 plus lambda equal to 2 mu. This one will be 2 lambda equal to 3 mu. So let's replace, let's make lambda the subject of formula. So lambda is equal to 2 mu minus 1. Replace this back in this, you will have 2 mu minus 1 equal to 3 mu. This becomes 4 mu minus 2 is equal to 3 mu. So mu is equal to 2. So the position of P will be R is equal to mu, which is 2, times this 2, 2, 3. That will be 4, 4, 6. So this is the position. So OP will be given by 4, 4, 6. Okay, that is part B. Now moving on to part C, we have to find the angle OPM. So OPM is OPM. So we have the angle, the OP has been given to us on this side. We have 4, 4, 6. We have to find MP. So MP is just OP minus OM. OP is 4, 4, 6 minus OM. OM is let's see, it is given to us as 310. That will be 4 minus 3 is 136. So 136 will be your value for MP. Now, as you know, the scalar product formula is A dot product of B is equal to modulus of A, B, and cos of the angle in between. So same way, we have to have one side which is OP, which is 446 dot B, which is this one 136, equal to modulus of A. The magnitude of this one will be 4 square plus 4 square plus 6 square. That'll be root of 68, and this one will be 1 plus 9 plus 36. That will be 46, and cos of the angle P. This one is pretty easy, dot product. So 4 times 1 is 4 plus 4 times 3 plus 6 times 6. That will be 52 equal to root of 68, root of 46, cos of P. Now cos of P is equal to 52 divided by root of 68 times root of 46. That will be 0.929758. So P will equal to cos inverse of that. You will have 21.6 degrees. And this will be your angle OPM. So that was the last question of this paper. I hope that was somewhat helpful, and as always, thank you for watching. I will see you soon.